In this lesson, you will learn how to solve the algorithm of loading the files to memory using a linked list. I hope you try to solve it yourself and thought about a possible solution to this problem. So we have our linked list here, and we saw that adding at the end of the list had a time complexity of O of n, and running the whole algorithm of loading everything to memory, all the words, was an O(n) squared. So the solution here is to not append to the list, but to prepend. Because the only pointer, the only reference that we have here is a reference to the first element. This is the only element that we can access directly. So usually when we create a new node, in the previous examples, we were using null at the end. So we were doing something like this. So linked list, and here with some data, and null, which would create a node like this, right? So it would be something that we have at the end. But there's nothing that forbids us to put something else here, right? So because we can do linked list with our data and list. So if we put our list here, then what we are doing, let's assume that this data is number 3. Then what we are doing is creating a new node with the number 3, and instead of pointing this to null, we are pointing this here. And if we keep doing this, then we will also load all the words from the file. But instead of adding to the end, we add at the beginning. And this would solve our problem. And let's look at how this can be implemented. So what we want now is a function called prepend, function list prepend, that, like before, needs some data. That is an integer, and our list is a linked list. So this doesn't change. So this is always the same. And returns a list, a linked list, that of course is not null. So it doesn't have the nullable here. And here the pattern is always the same. So if list is null, then this adding at the beginning or at the end is the same, because the list is empty. It will be just a list with one element. So this will be exactly the same as what we had before. Linked list with our data and null. But then this is the case where we are interested. And here, what we need to return a linked list with our data. And instead of null now, we want to connect to this list here. So here we write list. And this would be our solution. But if you look at this, if this list would be null, this would still be valid, right? So there's no reason to separate if the list is empty. So it would be, let's say, code optimization, because this is very clear, right? So if it's empty, it does this, otherwise it does this. But in this particular case, the code is the same independently if it's empty or not empty. So we don't need to write it like this, because just with one single line we can do both, and so it would look like this. So we can just return linked list with our data and our list. And if the list is null, then this will return data with null. So it's just one node. If it's not null, then it just connects the nodes. So this would be just a one line of code that solves our problem. And now we will see in action how this performs compared to using append. And before we go to the computer, let's analyze this so that you even see mathematically that this is much faster. So in this case, what we have here is what's called constant. This algorithm executes in constant time. This is represented by saying that it's O1, which would be a graph like this. X and Y, it would be something like this. This means that it doesn't matter the size of the input, the time that it takes to execute this function will always be the same. It doesn't matter if it's empty or if it has a million elements, this instruction will just execute with the same speed independently of the input. So this is represented by O1, and O1 means that it runs in constant time. So let's see this in action and you will see the huge performance improvement that we get just by this simple change. See you in the next one.